Welcome to Lifestyle by Design, helping you solve everyday challenges. I'm Karen Jacobs, a professor at Boston University, a Brookline Rotarian, and an occupational therapist. And here's my co-host.
Hi, and I'm Andrea Calso. Today our theme is From the Earth to the Universe. We have two guests here, so we're going to start with Robert Kaplan. He's the owner of OK to Age at Home, and his company does home modifications so that you can age in place. And we're going to hear a little bit more about that. So we're going to start here on Earth, and then we're going to travel up into the galaxy, and we're going to hear from Emmett Golden Marks, and he is a graduate student in astronomy at Boston University, and he's going to be talking to us about searching for galaxy clusters in the early universe using bent radio sources. And yes, I had to read that.
We have such an interesting episode for you. So let's go right into it. So Robert, we've known each other for many, many years. In fact, your wife was an occupational therapy student at Boston University. You're in a new field than you were years ago. So tell us, how did you get into this, and tell us about it?
Okay, it's very interesting, I think. OK to Age at Home. So we do home modifications for people who want to stay in their home and also people with disabilities.
Okay.
So I think it started actually when I first got married in the late 1970s. Fran was a recreational therapist at a nursing home, and I spent quite a bit of time at the nursing homes with some of the older people, and I felt very comfortable with older people. And then, I taught for a number of years, and I had a printing business for about 20 years. Recently, in the last 3 years, a friend of mine who is a general contractor was taking courses and setting up to work for older people, doing ramps and whiting doors. And he was a great contractor, but did not love going out and selling, and he didn't like the communication with people and people he didn't know. I, on the other hand, love that. I love going out. I love talking about the business. I love sitting with older people, people with disabilities, and talking about their needs. And Rick Betts asked me, gee, would you like to put this together? And I said, this was a great idea. So we teamed up and we created this company. And the third person also in the company is Rick's wife, Jane. So we have myself, who goes out, we speak to people, I speak to people, and Rick is the contractor and the technician and the designer in the company.
That's great. Now, you know, the AARP has done surveys, and they say that most people want to age in their home. They don't want to move in with their children. So it looks like there's opportunities for really making changes in people's lives so that the quality of their lives are what they want. So home modifications. Walk us through maybe what you might do in a hallway, an entrance, a bathroom, any of those. What might be some of the changes?
Alrighty. Well, home modification. So you're taking an environment. So someone might be older, or even someone in their 50s that are living in the home. They say, I want to live in this home through my 80s and 90s and maybe even,
further,
beyond. What are going to be some of my challenges? You stand at the bottom of the stairwell and you look up. Someone like myself, I can just run up the stairs. But my dad, who now is 90 years old, he can't walk up the stairs.
Right.
He's totally limited in his ability to walk up the stairs. He uses a cane and a walker, so he's marginally limited in going into the shower. And in, if he's with us, hopefully in a few years, that limitation will grow, and he'll need to take that walker into the shower with him. So you're going to need space. In a kitchen, right now, you can have a table, or you can have a counter, and relatively tight space around the counter. But an older person in a walker or a wheelchair needs a lot more space. So home modification, if you're challenged getting into your house, you're outside, you have to walk up 3 steps. Maybe in those 3 steps you might need a railing. You might need a ramp. In a house, you might have a carpet floor, and you can't use a walker on a carpet floor. So anything that we need to do within that structure would be a home modification. Now, AARP, and I have a document from AARP, has a number of pamphlets, but a pamphlet that I pulled off of the website and I printed it out, and they go through room by room with questions and answers, how to hire a contractor. They go into the kitchen, they go into the bathroom, they go into the hallway. And you can get from AARP, and this is the Department of Health, on things that you could read if you have someone that's older coming into your house. What are the things that a person can do, and what are the things that you might need to hire a contractor to do?
You know, these are all very important, I think, knowledge that we all need to know. We need to know and be proactive. As an occupational therapist, we go out there and we'll do the home evaluations, but we need someone to work with like you. It can be really expensive to make these changes. And I know that you make some suggestions on how people can fund making these modifications. Can you share some of those with us?
Oh, that's a great question. There are a number of ways of funding your project, and there is what's called, in Massachusetts, in our state, the Home Modification Loan Program.
Okay.
In the Home Modification Loan Program, you can get up to $30,000 to modify your home specifically for safety. So if you just want to, let's say, paint your living room, you couldn't use that. But as you get older, changing color from room to room is important, so you can differentiate one room to another. So you could utilize that money for something like that. In your bathroom, a lot of people have difficulty getting into a bathtub.
Right.
Or stepping over a high threshold. You could use the money to remove your bathtub and put in a nice large shower that has no threshold. It's tilted so the water doesn't come out, but it's totally level with your bathroom floor, and you can use a walker and walk right in, or you can take in a wheelchair. And that home modification funds could be used for that, for ramps, for railings, widening doorways. And the nice thing about the Home Modification Loan Program, and I'm working with a person in Amesbury right now, she has a reverse mortgage.
Okay.
And she was afraid. She goes, I can't get a loan. I have a reverse mortgage. My money is tapped out. The Home Modification Loan Program sits behind a reverse mortgage, sits behind a home equity loan. So you can have those and still get funded by this Home Modification Loan Program.
Is there a certain percentage for the interest on it? Is it? I would assume it's pretty low.
Depending on the amount of income you get, that Home Modification Loan Program could be a 0% financing, 0%, and no payments until the house is sold.
Oh, it's great.
So you can live your life, you can live on Social Security as long as you own a home or a trailer. You can get that money, and you don't have to worry about, how am I going to make these monthly payments? Even at no interest, monthly payments can be fairly high. And this way, it's 0.
Oh, what a great resource.
So you talked about widening doorways, modifying colors on walls, modifying the floor in the shower. I'm wondering, what are some of other common modifications that might be made? Because maybe you're thinking about doing this proactively, but how do you kind of think ahead and think about the modifications that might suit your needs?
Well, I'll answer that with two different answers. First of all, other home modifications that are very popular are stair lifts. And those are quite often covered by the home modification loan program. But you need to have that need for a stair lift. You can't say, I might have that need,
I see.
10 years from now. But other modifications that are done are your kitchen. We do a number of kitchens, and some of the things that are done, that if you have a disability that might put you into a wheelchair down the road, you can have your cabinets on certain kinds of levers that can come down.
Oh, wow. I've never heard of
Oh,
that.
no, they're beautiful. I saw a lot of them in Sweden. Very common there.
Gosh, that seems helpful for me now.
We'll come over and analyze your apartment. Get it all set up.
Yeah, and then sometimes you have cooking surfaces that are lower, that you can go in a wheelchair. You have sinks that are at multiple heights, and also underneath the sink there's no space, so you can come into a wheelchair.
Oh, wow.
You also can remove your throw rugs and carpets and have different kinds of flooring. So if I was going to put in a new kitchen now once I'm 55, I would look into what I'm going to do in that kitchen, what I'm going to need from here till 90 plus.
Yeah, so some of the things, we got this fixer-upper house, we were thinking of the future, and changing just the handles on the door to lever, that make it so much easier, and they're very attractive.
Very.
And that's the whole thing with what Robert does. It's not just modifying, but it's making it look appealing to wanting to live.
You had shared some photos with us, and I thought that, sometimes you think of home modifications, you think, oh, here's a handlebar there, and there's, a safety thing there. And I was pretty impressed, so maybe we can share a couple of those photos with everyone.
We just finished a project
see what we're talking about
on Plum Island. So I have a couple, and their mother moved in with them, and the mom's on the main floor of the house. And the bathroom had no shower at all. So
so you can swipe there.
Okay.
And then you continue to swipe that way.
Okay, that's great. So in this photo here, what we were able to do was we were able to knock out the wall about 18 inches and gave us enough space inside to create this walk-in shower.
Fabulous.
There was a window. We put a window in there and a little niche, and a handheld spout and a rain shower. So this particular bathroom not only allowed the mom to live on that same floor, but also increased the value of their home. And this is all tiled in. And then there's a little seat to sit on.
It doesn't even look like a seat.
Yeah.
It's so beautiful.
Yeah, it's really great.
So it's functional, and it's designed, and it's a lot of fun to shower in.
That's great.
So really quickly, before we move on,
because we're going to go.
We have this really nifty model too.
Tell us about the model.
We're all about the visuals tonight.
Yeah, tell us about the model here.
So Rick, my partner, is also a model maker.
Oh, that's great.
And when we started the business, he put this model together, and then when I do presentations, the model comes with us.
That's great.
And it's just a fun representation of being able to stay in your home and live comfortably through your years.
That's great. Well, now we're going to leave the earth,
the ground,
and we are going to head into outer space, but pretty far out into outer space.
Yeah.
So Emmett, got to meet you at Boston University. In fact, you did a similar presentation at my apartment, which is in the dormitory, and I was so impressed with what you're doing in your doctoral study that I told Andrea had to be on our show. So take us into cluster galaxies.
Okay, so I study galaxy clusters. So if you know what a galaxy is, galaxy clusters are these large, gravitationally bound systems of galaxies. So somewhere between 50 on the low end and thousands on the really rich high end of galaxies. And when I say they're gravitationally bound, I mean kind of like the Earth and the Moon, there's gravity that is acting between them. These galaxies all have that same kind of gravity. So I'm looking at finding galaxy clusters. So, you know, when you look at the night sky, you don't just like look up and be like, oh, look, there's a galaxy cluster, and there's a galaxy cluster. It's like, no, you see stars. And even if you look with more powerful telescopes, you see galaxies, but there's not, especially in the optical range, so in what we see, there's not an obvious, oh, look, right here, this is a galaxy cluster. You need to, you know, look at for specific amounts of overdensities. So you're looking, you know, are there more galaxies right here than over here? And if you see that, and then you can find if they're all at the same distance away, then they're likely associated. And then, so that's one of the easier ways, one of the more straightforward ways of finding galaxy clusters. There's a few other ways. So one of the things that makes them useful is that they're also really, really bright in the X-ray. So when you do X-ray astronomy, so instead of looking at it with optical light, you're looking at X-ray light. They're the largest extended sources. So you're looking for these extended sources, and that's another way of finding galaxy clusters. So we're doing it in a completely different manner. So we know we live in a galaxy, and most galaxies have supermassive black holes in their centers. And so because of this supermassive black hole, some supermassive black holes are what we call active galactic nuclei, which means that instead of just a black hole being there, there's an accretion disk, and you see these crazy radio jets coming out of this black hole. So imagine like you have a black hole and like an atomic bomb explosion on either side, but you can only see it in the radio. So you're seeing now in radio waves instead of in optical light. So that's kind of what an AGN is. So all of this matter is being accreted, and because of magnetic fields, things are getting pushed out in these really energetic jets, and you see these like plumes on either side. And we're looking for bent radio sources. Like most AGN are parallel, so they're like this. We're looking for ones that have a distinct, more V-like shape, and we're looking for these because if they have this V-like shape, that means that the galaxy that this AGN is associated in has to be ramming up against something else that causes it to be bent.
Like another galaxy?
It could be another galaxy. So one of the things we do think
could be. Oh,
it
God.
could be.
Right.
It could
well,
be
no,
another.
I thought that was the only option.
No.
So it could be. So it could be another galaxy. It could be another cluster. So sometimes if you have like two clusters merging, it could be just like gas in the galactic media, in the extragalactic medium. So if you have like gas or something else, there's some kinds of filament structures that could sometimes be ramming in. We find them preferentially in galaxy clusters where you're seeing the dense medium that the galaxies are in this cluster is causing the bending. So it's kind of like if my hand is this, it's getting hit and getting bent, kind of like that.
Oh, got it.
So I guess conceptualizing sort of like these things hitting each other, and every time you said supermassive black hole, I kept thinking of the Muse song.
Yeah, no, it's fantastic.
I'm sure you get that all the time. But I'm just wondering, like, trying to bring it back down to like Earth terms and my person, if I'm in a galaxy that's hitting another galaxy, what effect does that have on the things in the galaxy?
So the main effect would be that when you have galaxy mergers, you could increase the amount of star formation because you need, so you can like essentially like springboard star formation if you're having galaxies merge together. But from a physical standpoint, the odds of one star hitting another star and like causing some kind of crazy stellar explosion that would kill all of us on Earth are really, really slim. So I mean, in the nearest star in the Milky Way to us is another 4.3 light years away. So that's really, really far. So the odds, so our galaxy is currently in the long-term processes of merging with Andromeda. And when that happens, the odds of our star hitting another star really, really slim. So from a like tangential, like, is my life going to change if we merge with another galaxy? No.
Well, yeah, and maybe to put a different way, imagine we were. So what you're describing as these galaxies are hitting each other they're kind of like blowing each other up?
A little bit. They're kind of like, it can be sometimes kind of like one is sometimes if you have a larger galaxy and a small one, sometimes you say it's cannibalizing it. So like one galaxy is eating another galaxy. And there's a type of galaxy group that I've looked at that is specifically, we think of it as cannibalization. And I always like that because it's like little crazy guys eating other people. And it's just, so it's a big galaxy eating a little one.
That's incredible.
Yeah.
So you're going to tell us a little bit about your study because we have about 5 more minutes or so.
Yeah. So the study that I'm working on is called COBRA. So because of that bent shape, it can with the right source, it can kind of look like the snake. So it's the clusters occupied by bent radio AGN, and we look at some 653 of these bent radio sources, and they're saying, okay, the sources we're looking at are specifically in the farther universe, which means we're seeing light that has traveled a long time to get to us, so that light is significantly older. So some of the light might be as old as 10 billion years old that we're seeing. So most of it's going to be most of it's going to be like between 10 and 5 billion years. But we're looking in this early part of the universe. So not quite right after the Big Bang, but a lot closer to the Big Bang than to us right now. Because in astronomy, anytime you look back, you're looking back in time. Because light takes a finite amount of time to travel. So what I do is I'm using images from the Discovery Channel telescope. So the DCT is really cool because Boston University is a partner in the DCT. So any astronomer associated with Boston University can apply to get some of the 40 nights that we have. So I know my advisor and my research group is going to be doing some observing in February, and a bunch of other faculty are doing observing as well. And it's a 4.3 meter telescope. So we're taking this 4.3 meter telescope and pointing it for some hundreds of seconds, hundreds of thousands of seconds at a specific region of the sky and saying, okay, observe, and now are we going to see a galaxy cluster? So we take these really long observations, and then I get to break them apart and analyze them and look in specific regions around our radio sources and saying, are we seeing an overdensity? And if it's how strong an overdensity is it? Or are we not seeing anything there? So some of the sources we've found overdensities of 80 to 100 galaxies, and that's really good. That means, okay, there's probably a cluster there. Other times, I'll do my overdensity calculation, and it'll be negative. And it'll be, okay, that's not it. But you can't have a negative overdensity. That just means there's nothing there.
Nothing there.
It might just be a single galaxy in space.
Wait, now where's the telescope located?
So the telescope is in Happy Jack, Arizona, pretty much in Flagstaff, the Lowell observatories. And I got to go out there, not this past Halloween, but the Halloween of 2013, and they have an eyepiece on that telescope. So if you ever look through like an 8-inch telescope, it's pretty cool. Looking through a 4.3 meter telescope, it's like if you never ever saw an IMAX theater and like only had watched TV on an iPad. And then like all of a sudden someone took you there and it's like, look at all the colors. And like, look how big everything is. It was amazing. Like it was amazing. Like it made up for the fact of missing Halloween. Like, it was like totally like the highlight of my astronomical career. So I'm looking with, I'm working with some different people at BU, and we're doing this. We're doing this to find these high redshift, these early clusters, and that's because there are very few currently found. And so we want to find ones with a redshift above 1. And when we're saying redshift, I just mean so they're older in the they're coming from an earlier point of time, and we're creeping towards having some confirmations. There's a few that we've found that seem to have very high redshifts. So we're in the next couple months we should have some good results, and we're excited about that.
That's great. So what does that, I guess I just want to follow that thought for a little bit longer. What does that mean in terms of the galaxy clusters? And so you found them, and then then what?
so we've found these overdensities, and we need to just confirm So we have ways with models to say, okay, this is how old they are, and this is where they're coming from. But there's, if you can look at the spectra, so you can look at like individual line emission. So in the same way that if you have like a neon light, it emits at a certain wavelength for neon, and you'll see a very peaked emission. If you can look at an emission line, or so you can see how that line has been shifted, you'll be able to determine how old is this galaxy, or how old is the light that you're seeing. So we just want to confirm that before, as like the ultimate. This is how old these clusters are. This is when we're seeing their form. And once we have them, we'd like to be able to determine what is the effect of the AGN on the cluster. So what is the effect of having this really energetic source? So star formation requires cool gas. So so we know that it should inversely affect star formation. And so we'd like to look at the effects of how having one really loud AGN, possibly having multiple AGN, would on individual galaxies. And galaxy clusters are great because they all form at roughly all the galaxies in them form at roughly the same time. So like I can't go to the lab and make a galaxy and like be like, oh look, I made all these galaxies yesterday, and let's see how they evolve. So one of the ways to look at galaxy evolution is to look at clusters and how this set of this population has changed, or how their star formation is.
Wow, that's so interesting.
Yeah, I could go on for a long time now that I'm listening. I'm big into science fiction books and stuff, so this is like right up my alley. But
Nice.
I know, but
Nice.
we only have 2 minutes left. So
You'll come back. You'll both come back.
We'll
Okay.
both come back. So we've gone out into galaxy clusters and learned so much. And here we've learned about how we can really successfully age in place. And for us, both of them have a lot of relevance.
Yeah, they give a lot of meaning in different
does.
ways.
Yeah.
Think about your life in different ways.
And it does. And one of the things that I found so interesting, Emmett, the first time that I heard you speak, is that you can really bring it to a level that us lay people understand. And I love your enthusiasm for it. I hope someday we'll get to go to that telescope. And BU has an observatory too. On Wednesday, Wednesday nights. We could do that sometime.
Oh wow.
Yep.
Maybe we'll take a field trip with our show.
That would be so great.
Yeah.
But we want to thank both of you for being on
Robert.
our show.
Thank you, Emmett. This was really wonderful. We
Pleasure.
learned a lot. Thank you for joining us tonight. We are live here at Big TV, and this could be you. We're doing this, BU. Sorry. This show is part of our Thursday Night Live program. It's an opportunity for you to join and have your own show here and connect with everyone in the community. So thank you for joining us tonight. You can find out more information about Thursday Night Live on our website, brooklineinteractive.org. You can also watch other episodes of our show.
Right.
So check it out. And until next time, I'm Andrea.
I'm Karen.
And our guests. Thank you and have a good night.
Thank you.